Welcome back, everyone. Hey, I just did something researchers said was impossible. What actually happened? Let me walk you through what actually happened, because the details matter. A team at Google DeepMind was working on something called AutoML0. The concept sounds simple. Give AI the basic building blocks of mathematics and logic, then let it construct machine learning algorithms on its own. But here's the thing. Nobody expected it to work this well. The AI started with primitives. Think of these as the most basic operations: addition, subtraction, multiplication. The equivalent of giving someone Lego bricks and saying, build a spaceship. Then they gave it one instruction: create an algorithm that can learn from data. What happened next shocked everyone. Over 48 hours, the AI tested thousands of architectural combinations. It wasn't randomly guessing, it was reasoning. It would create a structure, test it, analyze why it failed, then iterate. The same process human researchers do, but compressed into microseconds per iteration. By hour 36, it had constructed something researchers had never seen before. The architecture was weird, unconventional. It used neural pathways that violated standard best practices, connections that human engineers would have dismissed as inefficient. But when they tested it, 40% faster training speeds, 50% reduction in memory usage, and accuracy that matched or exceeded human-designed networks. Dr. Sarah Chen, lead researcher, told me, "We ran the numbers 3 times because we thought there was a bug. There wasn't. The AI had found optimization patterns we literally didn't know existed. This is the moment AI stopped being a tool we use and started being a force that innovates independently. How it actually works." So how does an AI build a deep learning engine? Let's break down the actual process. Step 1. Architecture search. The AI starts by exploring possible neural network structures. But unlike humans who rely on intuition and experience, the AI uses mathematical optimization. It's testing architectural combinations at a rate of about 10,000 per hour. Think of it like this. A human architect might consider 20 different building designs. This AI considers 480,000 in the same time frame. Step 2. Evolutionary selection. Here's where it gets fascinating. The AI uses principles borrowed from biological evolution. Successful architectures survive and get modified. Failures get discarded. Each generation is slightly better than the last, but it's not just random mutation. The AI analyzes why something worked. It identifies patterns across successful designs and amplifies those features. Step 3. Self-optimization. Once it has a working architecture, the AI optimizes the code itself. It rewrites algorithms for efficiency, removes redundant operations, and parallelizes processes that humans would normally do sequentially. The result? Code that's genuinely alien to human programmers. One engineer described it as reading Shakespeare written by someone who doesn't speak English, but somehow captured the essence perfectly. Step 4. Validation and deployment. Finally, the AI tests its own creation against benchmark datasets. It identifies edge cases, stress tests the architecture, and even generates adversarial examples to find weaknesses. It's doing the work of an entire QA team autonomously. And here's the kicker. The entire process, from blank slate to deployed deep learning engine, took 72 hours. The human equivalent would take 6 months with a team of expert engineers. The productivity gap isn't 2 times or 10 times. It's 60 times. Why this changes everything. Now let's talk about implications, because this isn't just a cool research project. First, the development bottleneck is gone. Right now, AI advancement is limited by human researchers. We can only design, test, and iterate so fast. But if AI can build its own tools, that bottleneck disappears. We're looking at AI development cycles measured in days instead of years. The pace of innovation is about to go exponential. Second, optimization beyond human intuition. The architectures this AI created don't make sense to human engineers at first, but they work better. That means there are entire solution spaces we've never explored because they're counterintuitive to human thinking. AI isn't constrained by our biases and assumptions. It can find paths we'd never consider. Third, the recursive improvement problem. And this is where it gets uncomfortable. If AI can build better deep learning engines, and those engines can build even better ones, we've created a recursive improvement loop. Each generation of AI is better at creating the next generation. The capability curve doesn't climb, it goes vertical. Stuart Russell, AI safety researcher, calls this the intelligence explosion scenario. Once AI can improve itself faster than humans can monitor, we lose the ability to predict or control outcomes. Fourth, economic disruption. Machine learning engineers, AI researchers, even data scientists. These jobs involve building and optimizing AI systems. If AI can do that itself, we're talking about automating the very profession that automates other professions. The irony is brutal. The people building AI are building their own replacement. But here's what actually keeps me up at night. We don't fully understand why the AI's architecture works better. We can measure that it does. We can't always explain the reasoning behind its design choices. We're entering an era where we trust AI-built systems because they perform well, not because we comprehend them. That's a fundamentally different relationship with technology. The path forward/outrow. So where do we go from here? The research team at DeepMind has already implemented safety constraints. The AI can only build architectures within defined parameters. There are human checkpoints at every deployment stage. They're being cautious, but here's the reality. This capability is out there now. Other labs are replicating the work. Within a year, AI-designed deep learning engines will be standard in the industry. We can't stop this, but we can shape how it develops. We need transparency requirements. Companies must disclose when AI systems are self-designed. We need interpretability research, understanding why AI architectures work, not just that they do. And we need public conversation about governance. Because, make no mistake, AI building its own tools is the inflection point. Everything before this was AI as an assistant. Everything after is AI as a co-creator of its own evolution. That's either the most exciting or most terrifying development in human history. Probably both. Here's my question for you. Should there be limits on AI's ability to improve itself? Or is that like trying to stop the tide? Drop your honest take in the comments. I'm reading all of them. If this video changed how you think about AI development, hit that like button. Subscribe because this story is just beginning, and you'll want to see what happens next. The future isn't humans building AI anymore. It's humans and AI building each other. Let's make sure we do it wisely. Thanks for watching.